Thanks, everyone. So this talk, can we make it just a little quieter, maybe? Okay. So this talk will be about giving you the process and tools to find what's wrong with your build performance and then fix it. So this won't be a list of just copy-paste these 20 little snippets into your build. Sorry about that. You'll actually have to do some work after this. All right, so to improve your build performance, you should follow the same process that we follow at Gradle, which goes like this. First, you define the scenario that you want to improve. So what's wrong? Is it Android Studio Sync that's giving you trouble? Is it repackaging after a single line change? Is it your CI build, your clean build, that's giving you trouble? Define what you want to improve, then move on to profiling. I'll tell you about the tools that you can use for that in a second. And then, and this is important, identify the biggest bottleneck. I've seen this again and again, people improving something that they know. Just picking something like the 5th biggest bottleneck, because they know, oh, I know that piece of code, I can improve that. The problem is, it's just the 5th biggest bottleneck. It's not the biggest problem. So if you improve something that's only 5% of your build time, and you cut it in half, you've only saved 2.5%. On the other hand, if you improve something that's 50% of your build time, well, you get the idea. So you go and fix that bottleneck, and then, and this is again very important, you verify the fix by measuring again. I've also seen this way too often, just changing something, thinking that it will help, but not verifying that it's actually better. And so you might end up with a lot of extra complexity in your build without having improved anything. And once you've done that, well, repeat. Either at step number 3, identify the next bottleneck, or go back to 1. What do I want to make better next? Also, automate your measurements. It's way too hard to repeat proper measurements manually and tell your colleagues, oh yeah, I tested this task, I was changing this file, I did so many warm-ups. No, just use the Gradle profiler. It's a small command line tool that we've written for you. It allows you to define these scenarios. So for instance, I want to test my clean build. And then it'll do warm-ups for you, it'll do measurements, it'll do statistical analysis and tell you, here's your average time, here's your standard deviation, and so on. And it also lets you attach all kinds of profilers. So no matter if you prefer using JFR or JProfiler or YourKit, we got you covered. So before we dive into more specific advice, the very first thing you should always do is make sure you're up to date. Make sure you have the latest Gradle version. Make sure you have the latest Android version. Because otherwise, you might be hunting down performance issues that have long been fixed. So save yourself that time. And another word of caution, JVM flags. I've seen this quite a lot in other talks or on Stack Overflow, etc. Here, just add these 20 JVM arcs to your daemon, and builds will get faster. Probably not. The worst case scenario is you'll make your build slower or unstable. So my advice is just give the daemon enough memory and hands off all other JVM flags. Your time is much better spent improving your build on the structural level. There's much bigger savings to be had there. Okay, so first question is, of course, where's the problem? And this is where build scans come into play. So who of you has created a build scan before? All right. So for everyone else, build scans, you can create one by just adding --scan to your build, are a tool that collects all kinds of data about what happened in a build, which tasks were executed, how long they took, which plugins you used, which dependencies you had, how long each plugin took to be applied to your projects, etc., etc. And it presents that to you in this really nice web UI. So you can see a timeline of everything that happened in your build. You can see a performance breakdown. You can see if there's any problems with your daemon, any problems with caching, etc. And we're going to dive more into how you can find problems by looking at build scans. You can find problems in other ways. It's just more tedious. So, you could look at logs, of course, to find a similar wealth of information, but the presentation in the build scan is just so much more accessible. That's why I'm going to focus on that. So, let's talk briefly about the build lifecycle. Because depending on where your problem is, you want to improve different phases of your build. You want to focus on different aspects. Roughly, you can split your build into configuring and executing. So the configuration time is basically running all your build scripts, applying all the plugins, preparing the model of your software so that Gradle can then figure out which tasks to run. And then the execution time is all about running those tasks. So in build scans, you will see a nice breakdown telling you, oh, hey, your configuration time was 1.8 seconds. And executing tasks took almost nothing because I just called Gradle help. It'll also show you, coming back to the VM tuning, how much time was spent garbage collecting. You'll see if your heap is almost full, so that can tell you, okay, maybe I should give it a little more memory. So when you look at this performance breakdown view, what are the red flags? What should tell you, I really need to improve something here? Well, the first thing is, if startup, settings, and build source together take more than a second, that's bad. I see all the phones going up. Don't worry, those slides will be online soon. So startup should be really fast. You should have a well-warmed-up daemon. There should be no significant time spent there. Configuration time, it's a little harder to make an absolute statement there because it depends on the number of projects you have. But as a rule of thumb for Android projects, I'd say if it's more than 10 milliseconds per project, it's worth looking into. And I've seen much worse than 10 milliseconds per project. I've seen like 30 seconds for a 50 project build. It takes some creativity to make it that slow, but people manage. Next big red flag would be if a single line changed, let's say just changing a print line in your code, takes almost as long as a clean build. You want to definitely look into that. It means your incremental builds are broken. Or a no-op build, so you didn't change anything, you just say assemble debug, and then you say assemble debug again. If that takes any time at all, if it executes any task at all, you want to look into those tasks. They're doing work that shouldn't be done. And of course, high garbage collection time is always bad. So this might mean that your build has reached a size where the tools just need more memory than you're giving them. For instance, dexing is relatively memory intensive. So if you add 100 libraries to your build, then yeah, that's going to take some memory. You might want to increase it. So let's look at these red flags in turn. Startup build source and settings. It's actually pretty simple. Make sure you're using the daemon. Make sure it's well warmed up. Make sure you're not killing it all the time. If you feel like killing the daemon every now and then, there might be a memory leak in your build, or you might have other problems in some community plugin, or maybe in your own code. So if you had any problems with the daemon, you might want to get a heap dump and see if there's any plugin that's leaking memory, for instance. Otherwise, it's relatively hard to make a mistake in settings. The only thing that I've seen is when people try to find projects dynamically by scanning the whole project hierarchy for build.gradle files. Yes, that is convenient instead of listing all your subprojects, but it's also pretty slow. So if you want to do that, make sure you have lots of excludes. You don't descend into build directories and stuff like that. Yeah, otherwise, there's not much to go wrong here. Configuration time. Now, this one is the big one for Android projects, at least. So who has a configuration time of roughly more than 2 seconds on average? More than 2 seconds? All right. Everyone else is relatively well in good shape. I'm happy to see that. So configuration time, as I said, applying plugins, evaluating build scripts, running after evaluate blocks, etc. And it happens when you run any task, doesn't matter which. Can be Gradle help, can be Gradle tasks. It also happens when you sync with Android Studio. So whatever work you do at configuration time will slow down everything you do with Gradle. So you want that to be as little work as possible. So what usually goes wrong? Well, one thing is resolving dependencies at configuration time. You can see that quite nicely in the dependency resolution view of a build scan. It'll tell you, oh, my app runtime, for instance, was resolved in this example project. And so I look into the my app build Gradle file and I see, oh, this piece, configurations, runtime, collect, zip tree, it. That's eagerly walking over that configuration, getting all the files, and converting them to zip trees. So how do I fix that? I make it lazy, turn it into a little lazy closure, and the whole thing is delegated to execution time when that task is actually run. It's often little things like that. Sometimes also plugins that didn't really think about the distinction between configuration and execution. So you might see maybe some community plugin doing this as well. So you might want to get in touch with the author and say, hey, you shouldn't resolve that right now. You should do that in a task. Similarly, I/O. Gradle goes to great lengths to reduce I/O at configuration time. We compile your build scripts, load those classes, never touch those build scripts again until you change them. So you want to do the same. You don't want to do any I/O at configuration time. So defer reading any configuration files or whatever else you might want to do. Sometimes it's just an accident. So for instance here, who can tell me what's wrong with this task definition? Any takers? Yes, it does. It creates the file at configuration time. So there's a do last missing, right? It's doing its project stats generation at configuration time. So how would you see that? Well, you would see that there's this build script that is taking 200 extra milliseconds. So we look in there and we see, oh yeah, I messed up that task, forgot the do last action. Even better, I personally prefer writing task classes. When I have anything custom to do, I just write a task class, and I leave only the declarative parts, declaring the inputs in my build script, and I put the custom task into build source. What else can go wrong? Well, inefficient plugins. These are all coming from real-world examples. So somebody thought it was really cool to get some Chuck Norris quote on every build. And maybe that raised morale in the company a little bit, but it also raised configuration time by half a second on every build. Or what I also often see is getting the version by parsing the current Git revision. And what often happens is that people do this for every subproject. So you might see code like this. Do some exec command to get the current Git revision, and then apply that to every subproject. Or what that means, if you have 100 subprojects, you're going to go and call git ref parse 100 times. So instead, it's just a small tweak. Do it once, and then push the data into all subprojects. And this applies to any kind of expensive operation that you might want to do, like parsing some XML file, for instance. And one thing that is very Android-specific is the explosion of variants that you can quickly get. So you all know that you have build types and flavors, or flavor dimensions. And the more of those you have, the more variants you get. It's the cross products of all build types and flavors. So if you have debug and release, and then free and paid, and then you have production, QA, dev, whatever, you're quickly going to end up with 12, maybe 24. In one extreme example, I saw 400 variants per subproject. So you really want to reduce that by using the variant filter API to reduce the number of variants that don't make sense. For instance, debug prod. You probably don't want to send a debug build to production, so just remove that variant. Okay. Speaking of configuration time, we also have to talk about your build logic itself, even if it's not doing anything bad. I can warmly recommend splitting up your build scripts. Don't have one big script, because it's really hard to find a problem in there. The build scan will just tell you there's a problem somewhere in that 1,000-line build script. Instead, extract small plugins for each, let's say, each domain-specific thing. Like, I have a plugin here for my test fixtures, and one for my compiler settings, and one for getting the version from my current Git revision, etc. This just makes it easier to find problems. The next step would be taking those scripts and turning them into binary plugins. No matter if you write those in compile static Groovy or Kotlin or Java, whatever language you prefer, as long as it's statically compiled, you're going to be good to go. Because static compilation is really great for performance. If you have lots of subprojects and you have complex logic, complex computations to do, then using dynamic Groovy build scripts will slow down your build. And extracting stuff to build source also has the benefit that it keeps your build scripts declarative. So writing plugins, having extensions where the user just puts in some values, and then having the plugin do the heavy lifting is a good way to keep your build scripts declarative. Especially if you have a bigger team, you're the build engineer, you have 50 developers that you're servicing, then they will be very happy if they only have to deal with a declarative DSL while you take care of all the wiring underneath. And if you have to go down to the algorithmic level, for instance, a build scan told you this plugin is slow, but you just can't figure out why. You look at it and you see, looks fine. What's wrong here? You can, again, use the Gradle profiler with the, in this case, JFR setting, because from JFR we can create these really nice flame graphs. Who've you seen flame graphs before? They're all the rave right now. Yeah, I can see. So those will tell you, for instance, in this case, most of the time is spent in the Android plugin creating variants. So this would be a relatively well-behaved build. There is no other plugin visible here that's doing anything bad. It's just the Android plugin creating its variants. So this is a typical build where it's just many, many variants. This might be okay. This might just be how your build is, or it might be a hint to go and look for some variants that you could remove. All right, let's move on to execution time. Gradle's actually very smart about what it runs. So at execution time, it'll figure out which tasks to run. These tasks can be incremental, they can be cached, and then they can be parallelized. And of course, there's things that can go wrong at each of those stages. So incremental builds. One nice thing that you can do is just run a task and run it again immediately without any change and see if anything is rerunning. That is an immediate red flag. Nothing should be running if everything's up to date, right? So in this build scan, I see in the timeline view that almost everything is rerunning. Compilation is rerunning. Resource processing is rerunning. Packaging is rerunning. I didn't change anything. What happened here? Well, I drill down into this task and I see, this task was not up to date because the value version codes has changed. Where's that version code coming from? It's Crashlytics. Crashlytics, by default, and I don't know why they do that for debug builds. You might want to bug them about that. By default, it will create a unique ID every time you build. So in its default configuration, Crashlytics will completely kill incremental builds. So make sure, this is the one snippet that I want you to copy-paste, by the way. Make sure you tell Crashlytics to stop that on debug builds. In general, any kind of timestamp is going to kill local development performance. So don't put timestamps into your jar manifests, at least not on local builds. On release builds, doesn't matter. Yeah, you only do those once a day, once a week. Then incremental compilation. There's also a lot of stuff that could slow this down. So one problem is having one big monolithic module where all your code lives. This makes it very hard for Gradle to incrementally compile. Because when everything is in one source set and you do a change, Gradle won't go and parse Java files. That just would be, out of our business. We don't want to get into the business of parsing Java ourselves. So we can't tell whether it was an implementation change or an API change. So we'll just assume the worst. It's going to be an API change. Let's recompile everything that used this. If you modularize, on the other hand, and you change an upstream module, then on the downstream modules, we have class files. And class files are super cheap to parse, thanks to the awesome ASM library. So then we can actually look, what did you change? Was it the API, or was it just some little method body detail? And if it was just one of those details, then we don't need to recompile at all. Within a single module, it also helps to decouple your code for the same reason. So if you have this typical anti-pattern of a service registry that everybody knows and the service registry knows everybody, then no matter what you change, it's going to recompile everything. Whereas if you use the proper pattern, which would be dependency injection, where this injector knows everybody, but the individual classes know nothing about the injector, then when you change one of those individual classes, everything will be fine. Just that class and the injector will be recompiled, not everything else. So having interfaces between things and making sure that classes only reference what they really need is not just good practice and makes things more testable, it'll also make your build faster. So just one more reason to write good code. One word of caution about Kotlin migration. I know how excited you all are to migrate towards Kotlin and try out the language. What I currently don't want you to do is put one Kotlin file into a 10,000 Java file project. Because joint compilation between Java and Kotlin is currently very slow. JetBrains is aware of this, they're going to fix it, but right now it's problematic. Instead, extract a piece of code into another subproject, then migrate that to Kotlin, and then extract the next piece. That's the best way. Keep subprojects either pure Kotlin or pure Java. Now, I think there's an elephant in the room when I speak about incremental compilation, and it's not the Gradle elephant. And that elephant is annotation processors. Who of you uses no annotation processors? 2 people, 3 people. Wow. Applause for these 3 brave souls. Yes, so everybody uses annotation processors, which means currently, up until Gradle 4.6, you're not going to get any incremental compilation at all, because Gradle doesn't know what those annotation processors are doing. For all we know, they might be formatting your hard drive. They're arbitrary code. So we would have to switch off incremental compilation. But with Gradle 4.7, there now is incremental annotation processing in Gradle's incremental compiler. The only caveat is the processor developers need to opt in, because they need to tell us that their processor will actually work with this. So the early adopters are Project Lombok and Android State, and all the others, I welcome you to go to that issue on our issue tracker. There's a long list of processors with links to open issues or open pull requests. Go and bug them. Go and tell them, hey, this is what's slowing down my development cycles. This leads to a 1-minute recompile on every single change I do. Go fix that. So I already had a nice conversation yesterday with Jake about butter knife, so that's going to be fixed. The Google team, the Google team is working on data binding, of course, and we're also going to convince others like Dagger to finally opt in. So I hope that in a few months, annotation processors won't be a pain anymore. All right, now everything's incremental, but of course, if you do a clean build, for instance on CI, or if you do a branch switch and your branches are using different Gradle versions, then incrementality won't kick in. So you want to have fast clean builds and fast branch switches locally. How do you do that? That's what the Gradle build cache is for. Who's using the build cache? Okay, quite a few people already. Everyone else needs to start using it. So you can just activate it. All Gradle caching equals true, and you have your local build cache activated. There's also a remote build cache. There's a free implementation that you can use, and there's also our commercial offering, Gradle Enterprise, which has a distributed and automatically replicated cache. If you have a bigger organization that's spread over the globe, that would be very useful for you. So build scans, again, show you exactly how successful caching was, and how many hits you had, how many misses you had, or if there's any tasks that are not cacheable, and it'll also tell you the reason why those tasks are not cacheable. So maybe there is some community plugin that just didn't opt into caching yet. So caching will just take all the inputs, create a hash, look it up, and instead of rerunning the task, it'll get the results from the cache. And the local cache will make your branch switches very fast, and a remote cache can make your CI build super fast. So for instance, at Gradle, we have a setup where the first build in the pipeline compiles everything, builds everything, pushes to the cache, and then all the other builds that do all the testing, and we have like 300 of those, they can just pull the results from the cache. So they don't need to recompile anything. We don't need any complicated pipeline setups where we tell TeamCity to copy zips or anything like that. It's just task by task, Gradle will go and say, oh, have I seen this before? Yeah, just get it. So that makes clean builds on CI a non-issue. And of course, if you come to work in the morning, I just do a git pull, Gradle build, and everything's up to date because the CI server last night already built what I pulled. So I can get started right away with my work in the morning. Okay, on to the last bit of execution time, which is parallelism. By default, this is what your timeline will look like if you do nothing. So one serial execution of tasks. This will change in the future, so we're currently working on ways for plugin authors to say, actually, my task is safe to parallelize, and we'll also enforce that it's safe and fail if it's not. And that'll change this picture in the future. But for now, there is the option --parallel, which has existed for a very long time. It's basically a heuristic. It says, Gradle, it's safe to run tasks in different projects in parallel. And this works for 99% of all builds out there. That's why it exists. And it's really useful if you have well-decoupled projects. So if you have one monolithic subproject, you're not going to get any benefit from that. But if you modularized, then your builds are going to be much faster with --parallel. OK, so you've made your build much faster. The world is good. Now, how do you make sure that nobody breaks this again? How do you show your progress to your manager to get the promotion you wanted? How do you make sure that when you upgrade to the next Gradle version, you catch any regressions that we might have done? And this is, again, where Gradle Enterprise can help you. So you've seen individual build scans until now, which you can create for free, by the way. Gradle Enterprise allows you to collect those build scans in your organization. So every build that happens, no matter if it's on CI or on local developer machine, they're all collected centrally. And then you can search. For instance, you can say, hey, find me all the local builds. Find me all the local builds that took longer than this amount of time. I want to investigate them. Find me all the failed builds where, let's say, the assemble debug task failed. I want to investigate because somebody told me there's something wrong when they call that task. So this allows you to track what's going on in your organization. For instance, you could find all the builds that do a clean locally. I haven't done a clean in 3 years. Like, since I joined Gradle, I haven't done a clean build on our project. It's just not necessary, because Gradle has proper incremental build support. So why is this guy doing a clean build locally? Well, maybe they just don't know. They've worked on Maven before, and the only safe thing is doing a clean build. So maybe you just need to tell them, hey, you can stop doing that. It's all right. Or maybe they found a bug. Maybe you've written some custom task that just doesn't work properly when run incrementally. It's not picking up some change. So this might tell you, hey, somebody found a bug, just didn't tell you about it. And then you can jump into there and see, when was the last time that they didn't run clean? And by that way, tell when might the change have been that you introduced, and go and fix your task. And then finally, you can watch performance over time. So for instance, here, this dashboard will show you what's your average build time. How much are you saving thanks to the build cache? How much is the build cache costing you? What's your average configuration time, etc. So this is from our own builds. And you can see for the longest time, everything was fine. 1.5 second, 1.5 second configuration time. And then suddenly things started going crazy. What happened there? Well, actually nothing bad. We just migrated everything to Kotlin, so pretty much every commit during that time was a change to our build scripts. So that just slowed it down because the build scripts had to be recompiled. So nothing was really wrong there. nothing to worry about, and that line has gone down since. But it might be different in your organization. You might see your build times go up for real, even though you don't have a big migration going on at the moment. So you might want to investigate when that first bump happened. Did somebody add a new plugin maybe? Is that plugin badly behaved? You can just click on each of those bars. Each of those bars is one build scan. And you can compare them. You can do side-by-side comparisons of build scans, and it'll tell you the difference, like, oh, this had this plugin, which the other one didn't have. That might give you a hint that that's the problematic one. Okay, so this wraps up my advice to you for today. But I want to give you some extra resources that you can dive into. First of all, there's a bunch of talks today. Right in the next slot are Nikita Koslov and Boris Faber, who will talk about how your choice of language, project structure, and hardware affect your build times. Then there's another talk by Paul Davies called Compiling, How to Reduce Your Wait Times and Get Back to Work. And a talk by Ellen Nielsen called Modularization, How Hard Can It Be? Unfortunately, the last two are in the same slot, so you'll have to take your pick. There's guides covering every aspect of performance that you might want to look at. There's a Gradle performance guide, which talks about Gradle performance in general. There's also an Android performance guide, which is more of a cookbook, where you have little snippets of things that you might want to do to improve your developer builds. There's our plugin development guide. If you have Gradle plugins, Gradle tasks written of your own, then you might want to look at that, because it also explains performance-relevant features. And the structuring build logic guide, which helps you get away from that monolithic 1,000-line build script towards a more structured build. And if you take one picture today, if you take home one link, that's scans.gradle.com. So if you haven't tried them yet, try out build scans. Even if you can try it on your commercial product, because your company might not be okay with you trying out the free build scan offering, which is public, at least try it on your personal projects to get a feel for what you can find out and where the problems are in a typical Android build. And then it might be easier to convince your company to get a trial of Gradle Enterprise, to have it behind your firewall and collect your data. All right, that's all from me.